Good morning, dear students. In the earlier class, we discussed one-dimensional elastic collision, and in that video, we also derived the equation for final velocity of the bodies in one-dimensional elastic collision. Now we'll discuss completely inelastic collision. So here we prove in completely inelastic collision, kinetic energy is not conserved. So we want to prove kinetic energy is not conserved, and usually in completely inelastic collision, the final kinetic energy is always less than initial kinetic energy. So that's what we want to prove now. Now to prove this one, now consider two bodies. Yes, take a smooth surface and take a body which has mass m1, and let's say initially it is moving with velocity u1, and let us take a body which has mass m2, and let's say this body is at rest. For our convenience, we are taking the second body is at rest, and here collision takes place. And after the collision, so in the case of complete inelastic collision, what happens? The bodies stick and move together. So m1 and m2, they are sticking together and they are moving with the same velocity v. So initial velocity of the first body is u1 and initial velocity of the second body is 0, and after the collision these two are sticking and they are moving together. Now in any collision, remember, so momentum is conserved. So whenever collision takes place, this body exert force on this body and this body exert force on this body, and of course there is a normal force which is there is gravitational force which is acting downward direction, and the normal force acts upward direction. Net force in y direction becomes 0. So as a whole, the net force acting on this system is 0. So m1 exert force on m2 and m2 exert force on m1. These two are called internal forces. So the net external force acting on this system is 0. So the total momentum of this system remains constant. So here momentum is conserved, kinetic energy is not conserved. We prove kinetic energy is not conserved. The final kinetic energy is less than initial kinetic energy. Now let us apply conservation of momentum. So on applying conservation of momentum, now what is the initial momentum, guys? Initial momentum equal to final momentum. Initial momentum, only we have this body has momentum, right? The momentum of this body is 0. So initial momentum, right, pi is equal to pf. So pi means m1 u1, pf means, so after the collision, m1 plus the both bodies sticking and they are moving together. So this is the final momentum. Now can we write the equation for v? Yes, from this equation we can write equation for v, final velocity, that is m1 u1 by m1 plus m2. Now let us write the equation for initial kinetic energy. Initial kinetic energy, Ka, simply you can write Ki. So what is the equation we have? Of m1 u1 square. Now final kinetic energy. So after the collision, so both bodies are moving together, right? Of m1 plus m2 into v square. But what is v? For v, we already got this equation, right? Now of m1 plus m2 into v means you can write m1 u1 by m1 plus m2 whole square. Yes. In the next step, yeah, here what do we get? Yeah, let us write of m1 plus m2. Yeah, here you will get m1 square u1 square by m1 plus m2 whole square. This square and this one gets cancelled now. And what are the remaining terms we have? Of m1 square u1 square of m1 square u1 square by m1 plus m2. Yes, now I write this term. Yes, here I write, yeah, kf. Yeah, kf is equal to, I write like this, of m1 u1 square. Actually here we have m1 square, but I write only m1 u1 square of m1 u1 square. We have one more m1, right? Now we write m1 by m1 plus m2. m1 by m2. So here for initial kinetic energy we got of m1 u1 square For final kinetic energy we got of m1 u1 square into m1 plus m2. Now let us take the ratio kf by ki. So kf means this value of m1 u1 square into m1 plus m2, and initial kinetic energy this one of m1 u1 square. So this one gets cancelled now. So what is the remaining term we have? So kf by ki m1 plus m2. See guys, take now m1 and m2 values anything. So suppose this is 1 kg, m1 equal to 1 kg, m2 equal to 1 kg. What do we get? 1 by 1 plus 1. So we get 1 by 2, right? So that means, so whatever may be the values of m1 and m2, so clearly what is this ratio? This ratio is always less than 1. So what does it mean? So kf is always less than ki. Kf is always less than ki. Whatever may be the values of m1 and m2, when you take this ratio is always less than 1. So that means, so kf by ki is equal to some 0.5. So what does that mean? Kf is less than ki. That means, so what do you understand here? In complete inelastic collision, final kinetic energy is always less than initial kinetic energy. But according to law of conservation of energy neither be created nor be destroyed. So what happens is here, the body gets heated. So whatever the amount of kinetic energy is lost, so that amount of kinetic energy is converted to thermal energy. So this thermal energy gained by the body, that means the body gets heated. Yeah, this is about complete inelastic collision. Now let us define a new term, coefficient of restitution. Coefficient of restitution. Yeah. Yes, we define like this. Coefficient of restitution. The coefficient of restitution is defined as the ratio of relative velocity of separation to the relative velocity of approach. E is equal to v2 minus v1 by u1 minus u2. Yes. Suppose if we take one-dimensional elastic collision, so before the collision, two bodies are moving in a plus x direction. The velocity of the first body velocity is u1 and the second body velocity is u2. So whenever u1 is greater than u2, then only collision takes place, right? So that means u1, this body approach this body. That means, so usually if this body is velocity is 10 meter per second, the velocity of this body must be less than 10 meter per second. Then only collision takes place. If we take u1 minus u2, so this can be u1 minus u2 can be called as the relative velocity of approach. That means before the collision, what happened? The two bodies approach. The first body approach the second body. That means if you take u1 minus u2, this can be called as the relative velocity of approach before the collision. And collision takes place, and after the collision, what happens? The second body moves first with greater velocity than v1. Now if you take v2 minus v1, so usually v2 is greater than v1. So if you take v2 minus v1, that means after the collision, the two bodies separate, right? So if you take v2 minus v1, it can be called as the relative velocity of separation after the collision. So this ratio is called as coefficient of restitution. v2 minus v1 means the relative velocity of separation after the collision, and u1 minus u2 means so the relative velocity of approach before the collision. So v2 minus v1 is the relative velocity of separation, because after the collision the two bodies separate each other, and before the collision, so the body comes together and collision takes place, right? So u1 minus u2 means the relative velocity of approach before the collision. So this ratio is called as coefficient of restitution. So if this ratio, so based on this ratio, we can decide whether the collision is elastic or completely inelastic or simply elastic. Now let us see the values of E for the different types of collisions. Yes. For perfect elastic collision, E is equal to 1. In the case of one-dimensional elastic collision, we got this equation. u1 minus u2 is equal to v2 minus v1. Yeah, we said this equation number 5 or something. We got this equation. So from this equation, bring this. Yeah, it can be written as u1 minus u2 into 1, right? Now bring this u1 minus u2. So 1 is equal to, what do we get? v2 minus v1 by u1 minus u2. So we are defining this quantity as E, right? Coefficient of restitution. That means 1 is equal to, what do we get? E. That means, so for a perfect, not completely, for perfect elastic collision, simply we are calling it as elastic collision. For perfect elastic collision, what is this ratio? This ratio is equal to 1. So coefficient of restitution, if coefficient of restitution is equal to 1, then the collision can be called as elastic collision or perfect elastic collision. Now let us see the second type for inelastic collision. For inelastic collision, E value is greater than 0 and it must be less than 1. It must be less than 1. For inelastic collisions, so the coefficient of restitution value is, it is greater than 0 and less than 1. And we have one more type of inelastic collision, that is for completely inelastic collision. For completely inelastic collision, E is equal to 0. E equal to 0 because, so what is V1 and V2, guys? So we are defining E is equal to V2 minus V1 by U1 minus U2. But in the case of completely inelastic collision, so before the collision the body moves separate, but after the collision the bodies stick and move together, right? That means, so V1 equal to how much? V2. U1 and U2 are not same. U1 equal to 0, U1 equal to some value we have, U2 is equal to 0. U2 may be 0 or may not be 0. But after the collision, what's happening? Both bodies stick and move together. So V1 equal to V2 equal to V, right? So that means what about V2 minus V1? V2 minus V1 becomes 0. So 0 by something? 0. So that is the reason why for completely inelastic collision, the coefficient of restitution value is 0. So remember, for elastic collision or perfect elastic collision, E is equal to 1. For inelastic collision, E equal to, the value of E is greater than 0 and less than 1. For complete inelastic collision, E must be equal to 0. Yes. Now we want to determine coefficient of restitution between two bodies. So here we are taking a body which is ball and another one is plank or plate, whatever called. So we take this body as M1 and a plate which is placing on the ground. We are taking this body as M2. So we are leaving the ball at a height h1 from the plate. So it falls down and it makes collision with the plate and it bounces. It bounces and it moves up. But usually if it falls from a height h1, it will not move to height h1. Usually it moves less than h1. Let us call this one this height. The second height through which it is moving is h2. So initially it is falling down from height h1 and it is making collision with the plate. So when collision takes place, so this velocity is, before the collision, the velocity of the first body is, we are calling it as u1. And after the collision, it bounces up with some velocity. We are calling that velocity as v1. So u1 and v1, these two belong to which body? The first body, ball. You can also call it as m1. You can also call as m1. So before the collision, the velocity of ball is u1, and after the collision it bounces up with velocity v1. But what about the initial velocity and final velocity of the plate? 0 only, because before the collision it is at rest, just before the collision, and just after the collision also the plate is at rest. So u2 and v2, these two are 0. But what about u1 and v1? Are they 0? No, they are not 0. So it is falling down, the ball is falling down from height h1, and after the collision it is moving to height h2. So after the collision it has to move with some velocity, right? So that velocity we are calling it as v1. Now let us derive the equation for u1 and v1. In terms of u1 we will get in terms of h1, and v1 we will get in terms of h2. So after getting values for u1 and v1, we can get equation for coefficient of restitution. Yeah, here coefficient of restitution depends on the materials through which the bodies are made. So if two bodies are participating in a collision, so the coefficient of restitution between the coefficient of restitution of the collision depends on the materials with which the bodies are made. So here we are saying that the ball is made up of material 1 and the plate is made up of some material 2. We are calling simply material. We are not mentioning whether it is rubber or steel or anything. Simply we are saying material 1 and material 2. Now let us derive the equation for u1. So to derive the equation for u1, so take this is the initial position and take this is the final position. So we are using this equation for the first motion while it is falling down. While the ball is falling down, use v square minus u square equal to 2as. V means here final velocity. Here the final velocity. Final velocity is u1. U square means initial velocity. For a freely falling body, what is initial velocity? 0, 0 square, 2. So what do we get? Minus g, because it is falling down. And what is h1? Plus h1 or minus h1? It is moving downward. So the displacement is negative. So minus h1. So u1 square equal to minus and minus, what do you get? You get 2g h1. But what about u1? u1 is equal to, we get square root of 2g h1. See guys, whenever we get square root, this value may be positive, may be negative. But clearly here, before the collision, what's happening guys? So the ball is moving down. The ball is moving down or up. Just before the collision, it is moving down, right? So u1, you can write it as minus square root of 2g h1. Whenever we have square root, either we get plus or minus value. But here we take minus only, because the minus indicates downward direction. So u1 is equal to, what do we get? Minus 2g h1. Now in the similar manner, while the ball moving up, again use v square minus u square equal to 2as. V means final velocity. When the ball moves from here to here, the final velocity is 0, right? 0 square. And u square means initial velocity. When the ball moves up, initial velocity, it is starting with velocity v1, right? So take v1 square. And 2. A means acceleration due to gravity, it is always negative. And displacement, yes. So displacement from here to here, it is moving up or down? Up. So displacement is positive. Let us call it as h2. Now v1 square, we have minus v1 square minus 2g h2. So v1 square is equal to, what do we get? 2g h2. And v1 is equal to, what do we get? Square root of 2g h2. Plus or minus? Plus only, because the ball is moving up, right, after the collision. So the velocity of the ball must be taken as positive. But here we are taking minus. Why? So just before the collision, the ball is moving down. But just after the collision, the ball is moving up. So it is plus and it is minus. Now according to definition, what is coefficient of restitution? So v2 minus v1 by u1 minus u2. u1 minus, clearly in this collision, so this is m1, the mass of the plate is m2. And this is u1, this is v1. And what about u2, v2? Initial velocity and final velocity of the plank 0 only, right? So v2 minus v1. So v2 is how much? 0 minus v1. Minus v1 means, so square root of 2g h2 divided by u1. u1 means the velocity of the ball just before the collision. So what is the equation we have? Minus 2g h1. u1 minus u2. u2, what is u2? Velocity of the plate. So here, I forgot to write mass. So m2, let's say m2 is the mass of the plate. So the velocity of plank just before the collision, after the collision. So u2 equal how much? 0, minus 0. And minus minus gets cancelled. Minus minus gets cancelled. So E is equal to, what do we get? Square root of 2gh2 by square root of 2g h1. Square root of 2g, square root of 2g, if they gets cancelled. So what do we get? The final equation, square root of, here we have h2, here we have h1. Square root of h2 divided by square root of h1. So we can write square root of h2 by h1. So based on h1 and h2, we can decide whether the collision is elastic or inelastic, or completely inelastic also. So if h2 equals 0, yes, simply, I'll explain this one. So based on h1 and h2, here I'll explain. Suppose we are dropping a ball from height h1, and if the collision is perfectly elastic collision, what happens guys? Again it reaches to the same height, h2. That means h1 equal to how much? h2. h1 equal to h2. If h1 equal to h2, what do we get? E is equal to, we get 1. E equal to, we get 1. But if h2 is less than h1, sorry, if h2 is less than 1, that means not this height, somewhere this here, the ball is falling down from this height and it is reaching to this height h2. If h2 is less than h1, so clearly what do we get? E will be less than 1. E will be less than 1. Or simply the ball is coming down and completely it is sticking to the ground or plate. So h1 is the height, initial height. And what about h2 here? h2 is equal to 0. Now substitute h2 equal to 0 here. Substitute h2 equal to 0. 0 by something 0. So in this case, what happens? E equal to 0. So sticking means, so which type of collision is this? This is completely inelastic collision. That means for completely or perfect elastic collision, the body moves to the same height. H1 will be h2 and E is equal to, we get 1. For inelastic collision, the ball will not reach to the same height. So h2 is less than h1 and E is less than 1. If the ball falls and completely stick to the ground, h2 will be 0. If h2 equal to 0, if h2 is equal to 0, E will be equal to 0. So based on these h1 and h2 values, we can find or we can determine the coefficient of restitution of the collision. Yes. Now let us see how we solve two-dimensional elastic collisions. Suppose a body which has m1, let's say it is moving with velocity u1 in plus x direction, and we have body m2, it is moving with velocity u2 like this. And here they approach, this body come here and this body comes here and collision takes place. So after the collision, let's say the first body is moving with velocity v1 this way, and let's say this angle as theta1, and the second body is coming here and the collision is taking place, and the second body, let's say it is moving like this. The second body is moving like this. The two bodies are coming here and collision is taking place, and the first body is deflecting like this and the second body is deflecting like this. So let's say this angle is theta2. And if it is completely if it is elastic collision or perfect elastic collision, whatever you call it. So what happens, guys? Momentum is conserved and kinetic energy is also conserved. So usually this m1 u1 and m2 u2 values are given, and they will be giving v1 or theta1, and they ask us to find the remaining things. So then we apply. On applying that, just I am telling you how to solve the problems. On applying conservation of momentum in plus x direction, that means not plus x direction. Simply you need to say x direction. So what is initial momentum, guys? So initial momentum, that is initial momentum in x direction is equal to final momentum in x direction. So initially, so this body is only moving x direction. We take this is plus x axis, this is plus y axis. So initial momentum in x direction, how much? m1 into u1. So do we have any x momentum of this body? No, it is moving towards y axis, right? No, so this body doesn't have any x momentum. Now pfx, that means, so here we need to take the x component of momentum of this body and x component of momentum of this body. So for this one, what do we get? m1, we need to take v1x, that means x component of velocity. X component of velocity means what do we take? v1 into cos theta 1. Next, the x component of momentum of this body, m2 into, do we take v2 or v2 cos theta? v2 cos theta 2. So this is the, when we apply conservation of momentum in x direction, we are getting this equation. Let's say equation number 1. Now on applying conservation of momentum in y direction, so what do we write? Before the collision, piy is equal to pfy. Before the collision, the total momentum is equal to after the collision. So before the collision, what is the momentum, guys? So this body is only moving towards y axis, right? So this body is not only moving towards x axis. So m2 into u2, this is the initial momentum of the total system, m2 u2. Now after the collision, so what's happening? See here. So this body, take the y component of velocity of this body. That is y component of momentum. So m1 v1. So in x direction we get x direction we get cos theta. In y direction what do we get? We get sin theta. So here we need to take m1 into v1y. Here we need to take m1 into v1x. v1x means v1 cos theta. m1 v1y means m1 v1 sin theta 1 plus now m2 v2. m2 v2 the y component of this velocity. Y component of this velocity. So what do you take? m2, but we need to take minus sign, minus v2 sin theta 2, because so when you take the y component of this velocity, x component you will get like this, but y component you will get negative y axis, right? You will get towards negative y axis. That's why we need to take minus v2 sin theta 2, minus v2 sin theta 2. So this is the equation you are getting, second equation. So you are applying conservation of momentum in x direction and we are applying conservation of momentum in y direction. So we are getting this equation, and we need to apply one more thing. What is that? We need to apply conservation of kinetic energy. We need to apply conservation of kinetic energy, because which type of collision is this? This is elastic collision. We know that in the case of elastic collision, what happens? Kinetic momentum is conserved and kinetic energy is also conserved. Now, on applying conservation of kinetic energy, conservation of kinetic energy. So initial kinetic energy equal to final kinetic energy. What is that? Of m1 u1 square plus of m2 u2 square. This is the initial kinetic energy. Kinetic energy of this body plus kinetic energy of this body. And kinetic energy next, what is the final kinetic energy? Of m1 v1 square plus of m2 v2 square. This is the equation number 3. Now we solve these three equations. Now we will find the unknown values. Of course, the two-dimensional collision, it is not simple as one-dimensional collision. It a bit lengthy process. When we solve the problems, yeah, we use these three equations: equation number 1, equation number 2, and equation number 3. Just I am telling you how to apply conservation of momentum for certain axis, that is x-axis, for y-axis, and we apply conservation of kinetic energy like this, and we solve the equations. So known values we substitute. Suppose m1 u1, m2 u2, suppose theta 1 values are given. We substitute these three values. Now we can find theta 2, v2, and v1. Now we can find the unknown values. Yes. Now let us see two-dimensional completely inelastic collision. Yes. So for example, yeah, body m1, it is moving with velocity u1, and we have another body here m2, it is moving with velocity u2, and here this body is coming here and this body is coming here. So in the case of complete inelastic collision, what happens, guys? The bodies stick and they move together, right? So after the collision, let us assume the two bodies are sticking and they are moving towards this way with velocity v, and let's say this angle is theta, and usually in problems m1 u1 and m2 u2 values are given and they ask us to find theta and v. Now here what do? We apply conservation of momentum. Yeah, in this case momentum is conserved, but what about kinetic energy? Is it conserved? So kinetic energy is not conserved because it is completely inelastic collision. So in this case, certain amount of kinetic energy is lost. We know that the final kinetic energy is less than initial kinetic energy. So here let us apply conservation of momentum in x direction and in y direction. So simply I am saying in x direction. In x direction, initial momentum equal to final momentum. What is the initial momentum, guys? In x direction, m1 u1, because in x direction we are taking momentum, initial momentum of the whole system, m1 u1, and after the collision both bodies are sticking and they are moving together. So what do we get? m1 plus m2 into v. We get v. This is the total momentum, but we need to take x component of momentum, right? So we get cos theta v sin theta. So if we resolve this velocity vector in two components, with this side we get v cos theta and this side we get v sin theta. But which component are we supposed to take? This component, right? X component. So here we get v cos theta. Let's say equation number 1. Now in y direction, now we want to apply conservation of momentum. So in y direction, so initially the body is moving toward this way, right? So initial momentum of the system m2 u2, and after the collision m1 plus m2 into v. We need to take v, but we need to take y component, right? So this is the initial momentum of the whole system in x direction, and this is the final momentum of the whole system in x direction, and this is the initial momentum of the whole system in y direction before the collision, and this is the total momentum of the system after the collision. So we take v sine theta. Let's say question number 2. Now we can find theta. How do we find theta? Yes, now take equation number 2 divided by equation number 1. Equation number 2 divided by equation number 1. So what do we get? m2u2 by m1u1 equal to, so this side what do we have? m1 plus m2 into, this one, sine theta, m1 plus m2 into v cos theta. This one gets cancelled, this one gets cancelled. Sine theta by cos theta, what do we get? Tan theta. So m2 by u2 by m1 u1 is equal to, we get tan theta, sin theta by cos theta. From this equation you can find theta is equal to tan inverse m2 by u2 by m1 u1. Using this equation we can find theta value. After finding theta value, what we do is just we solve in this equation, then we can find v value also. So this is the way we solve two-dimensional completely inelastic collision. Hope you understood this concept, and comment if you have any doubt.